Welcome to Spring LIB.
Hello, in the question we have given bumper cars have elastic collision with one another but inelastic collision with people. So now the first part of our question is, so there are three questions. So the first one is your bumper car is traveling at 2 meters per second. So let us say our car, so our car is having the initial velocity u1 that is of 2 meters per second. So u I will be calling for the initial velocity and v for the final velocity. So now our car is represented by this index 1. So the total mass of you and your car is 350 kg. So m1 is given to be 350 kgs. So this is our car. So an empty motionless bumper car. So we have another empty car. So its initial velocity u2 will be equal to 0 meters per second and the mass of this empty car is equal to 250, sorry, this is 250 kgs. So now what we have to do is, so how fast in meters per second the empty bumper car will move after the collision. So and the collision is taken to be head on. Now if we solve the equation of, so if we solve the momentum conservation and this kinetic energy conservation, so we will land up with this equation. So v2 is the velocity of the final velocity of empty car, so that is given by 2m1 u1 divided by m1 plus m2 plus m1, sorry, m2 minus m1 divided by m1 plus m2 times u2. So we get this equation after solving the head-on collision for head-on collision. So momentum conservation and kinetic energy conservation, if we solve that equations we will land up with this equation. Now as this u2 is 0, so this term will go to 0. Now if we plug the value, so it will be 2 into m1. M1 is 350 times u1, so u1 is 2 divided by this m1 plus m2, so that is 350 plus 250, which is nothing but, so if we calculate this, so v2 will be 2.3 meters per second. So the empty car is moving with an speed of 2.3 meters per second. Now in this only, so the second question is how fast your car move in meters per second after collision. So our car, so our for our car the velocity will be v1 and that is given by 2m2u2 divided by m1 plus m2. So this is 1, then plus m1 minus m2 times u1 divided by m1 plus m2. So this is the velocity. Again by solving the momentum conservation and kinetic energy conservation we get this. So now as u2 is 0, so this term will go to 0. So v1 if we plug the value, so this will be 350 minus of 250 into 2 divided by 350 plus 250, and if we solve this, so what we are going to get, so v1 we will get it as, so this will become 200 divided by 600, which is 0.3 meters per second. So this is the speed of our car. Now in the third part, so we have the third part as well. So in the third part you are traveling at 2 meters per second again, but this time a 90 kg person is in your path, so you crash into him and he falls into your car. So this is clearly an inelastic collision. So what is the new speed? So we will use the momentum conservation over here. So now using momentum conservation, we will write m1 u1 plus m2 u2, that should be equal to m1 plus m2 times say some final velocity, because if that person is on our car, so it will also move with the same velocity. So from here, now this becomes 0 because that person is standing still, so this is 0. So we get from here the final velocity as m1 u1 divided by m1 plus m2. Now if we just plug the value, m1 is 350 times u1 is 2 divided by 350 plus 90, because the weight of that person is 90 kgs. So from here, if we calculate this final velocity, so it will turn out to be 1.59 meters per second. So the speed of our car after the collision will be 1.59 meters per second. I hope you find this solution useful. Thank you.